elaborate mating habits, a yellow submarine, and a Scottish tower. It can only be the Planet Earth podcast. Hello, I'm Richard Hollingham, and later I'll be meeting an underwater robot.
That's part of life at sea. All's great when it's calm, and hold on tight when it's not.
We'll also be judging some bowerbird impersonations. For this week's podcast, I've come to a Scottish hillside about 10 miles north of Dundee, and I'm standing underneath a very tall tower. It's actually called the Angus Tall Tower. It's because it's in Angus, and it's a tall tower. It's a TV tower covered in transmitters, and we're surrounded by fields of sheep, and behind me heather moorland, the heather just coming into bloom. Very windy day, but beautiful. And John Moncrief from the University of Edinburgh is with me. Now, you're not interested in the TV transmitter. You're interested in the instrument right at the top of this tower, sniffing the air.
That's right, Richard. It's not so much an instrument, it's more just a tube. We actually have a long tube which goes from the very top of the tower, which is about 220 metres up, and we sample air down this tube into some analysers which we have in a cabin just in front of us.
And what are you trying to measure here?
I'm really trying to measure very accurately the greenhouse gas concentrations of the air as the air moves past the tower. So I'm interested in the concentration of the three big greenhouse gases: carbon dioxide, methane and nitrous oxide.
Now this tower, just squinting to see the top, particularly in the sunshine, it's what, 200, you said 220 metres high?
Our sample's at 222. The whole thing with the television aerial is probably 250 metres tall, so you really have to crane your neck to see to the very top. Unfortunately, you can't see the tube because it's a very narrow tube. It's probably only a centimetre or so in diameter, and all the other pipes and cables and so on just mask it, just hide it.
Okay, so you've got this tube, almost like a hose pipe, I suppose, coming down the tower, through this cabling duct, and then behind us through this door.
That's correct, yes. Let's go inside and see the instruments. Okay, just step in here. And welcome to Tall Tower Angus, or at least the instrumentation at the bottom of the tall tower. And this is where everything happens, really. This is where we measure all the greenhouse gases to a very high level of precision.
So you've got a stack of shelves with, well, there's a computer on one, there's a mass of tiny little, very fine tubes on the other, and occasionally it's emitting a bit of a belching sound. And you're measuring greenhouse gases now, from the atmosphere now.
That's correct, yes. The air will have taken a couple of seconds to travel down from the top of the tower, and it's now going into a number of different analysers. So we have a CO2 analyser, we have another analyser which measures methane and nitrous oxide and sulphur hexafluoride. And then on the very top, if you have a look, Richard, there's a blue analyser which is measuring the amount of hydrogen in the air and also the amount of carbon monoxide in the air as well. But yes, they're all being measured instantaneously as we stand here.
Why? What's the point of this?
Well, I want to know what the concentration of greenhouse gas is in the air now, and I want to know what it will be in the future as well. So this site will be here for a number of years, hopefully, and we've been operating for the past 5 years. We're trying to build up a picture of how the greenhouse gases change over time in this particular location. And the reason we're on a tall tower, we take our samples from a tall tower, is that the samples that we observe at the tall tower actually reflect what's going on for many hundreds of kilometres upwind. In this particular day we have a strong westerly wind, so the sample that we're measuring right now will have come probably from Ireland several hours ago.
Well, let's have a look outside, because you're on this hilltop. You can look down over, that's what, the Tay down there. You can see the Tay Bridge and Dundee, and then over behind us, well, there's a transformer buzzing away. This heather, we look west. I mean, you can't see much beyond this hill, but the wind is coming that way, and I suppose it's coming, the Northern Ireland, the Irish Sea, Western Isles, Glasgow, and then a vast tract of countryside, and it's hitting here, and that's what you're measuring.
Well, that's right. We're actually interested in measuring not just the stuff that you see in the local fields. In fact, I suspect we wouldn't pick up the air that's coming from the local fields, because being so high up, 220 metres up, we're probably sensing air that's come from Ireland, possibly from the Atlantic. Indeed, there are some days you can actually measure the carbon monoxide that's come off forest fires in Canada. It can come that far, and our instruments are that sensitive that we can actually sniff the air coming from a different continent altogether.
And what are you finding? I mean, you're presumably seeing a natural process. You're also seeing our contribution, the human contribution to greenhouse gases?
Well, we are. In particular, we were looking at methane and carbon monoxide to look at the anthropogenic influence. Carbon dioxide is a very interesting gas, of course, because it reflects really what the natural vegetation is doing. So we see a trend in CO2 over the 5 years that we've been here, but we also see cycles in that trend as well, and that reflects what the biosphere is doing, what the oceans are doing, what the land surface is doing. But also sometimes if you're looking at carbon monoxide or methane, you see spikes or sudden increases. And they may well be because the air which is coming past our tower has actually gone past perhaps Dundee or Glasgow or somewhere else. So we can actually at times detect a human influence on our signals as well.
Can you give me an example then of something you've seen that you can say, well, that's a result of a particular activity?
Particularly on a calm, clear night, when the atmosphere is very stable, there's not very much mixing going on. Perhaps you'd have a southerly wind at this site, and what we'd actually do is we would sniff Dundee. You could actually get the carbon monoxide or methane or even the CO2 coming from Dundee, and we'd see that as a relatively high peak in our data. And then as the day went on, as more mixing came along, that would go away and we'd start to see the natural influence.
And that is the point, really, isn't it? You're measuring, okay, what's happening now, but you're looking at the trends and you're seeing what is happening to the atmosphere over time.
I suppose what drives this science really is where are the carbon sources in sinks? We really don't know where carbon goes once it leaves your tailpipe or your chimney. We know about half of it stays in the atmosphere and about half of it goes in the oceans and the land. But there's a bit of uncertainty about where it all goes, really. So what we can do with our very precise observations in conjunction with some modelling, we can actually see where these gases came from. And so if we see changes in the gas concentration over time, perhaps they're related to what's going on in the land surface. Perhaps you've got a drought in a forest, or perhaps you've got a forest fire, or you've got methane fire, peatland fire, something like that. So we can detect these things with the observations that we make. So it's a bit like a detective story. We can actually interrogate our data and figure out what the land surface or what the ocean is doing.
Well, thank you, John, and we'll post some pictures of this tower in the sunshine on the Planet Earth online Facebook page. This is the Planet Earth podcast, and next we're going to head south to Edinburgh to meet a scientist studying bowerbirds. Now, these birds are best known for building their bowers, elaborate arenas where they show off to potential mates. What you might not know is that bowerbirds are also excellent mimics. I went to Edinburgh Zoo to speak to Laura Kelly, a researcher from the University of Edinburgh, and senior bird keeper at the zoo, Gavin Harrison.
This is actually Rainbow Landings, a fairly new exhibit to Edinburgh Zoo, and we have a large flock of rainbow lorikeets in here, and basically the public can come in and feed the birds nectar, and the birds will fly down and feed the public, so it's a great experience for them, really.
Now, we're not going to talk about those birds, we're going to talk about bowerbirds, which you can't find in any zoo in the UK, hardly any zoos around the world, only really in the wild. What gets you excited, Gavin, about bowerbirds?
They've got fascinating repertoires and mating rituals. Some of them are more brightly coloured, and these birds seem to make the mess endowed bowers, if you like, and then some of the more drabber species will make these huge structures, up to 1 metre plus tall, really, so they're fascinating birds.
Laura, you've seen some of these bowers. They're just for mating, these things?
Yes, they're purely used for mating, no other purpose. The species that I work on, spotted bowerbirds, they build a long U-shaped bower. It's about 50 centimetres long, and they construct that out of a stick base, and then they put grass pieces along the side of the bower, and then in the middle of this bower they put pieces of green glass and clear glass, and then they have a big pile of snail shells at either end.
And it's not just that, they also mimic other birds and in fact other animals, other things in the world.
Yeah, so they mimic up to 14 bird species that we've got recordings of. They definitely mimic a wide variety of sounds and, as you mentioned, environmental sounds, including people.
Well, let's talk about that mimicry, because that's what you've been looking at. I think we can hear some of these. First of all, this is what a bowerbird would normally sound like. So almost a hiss-like sound.
Yeah, it's a very harsh, broadband kind of hissing sounds, and all the bowerbirds produce quite a similar kind of harsh sound. And this is the vocalisation that they use when they're kind of communicating with each other.
But they can also produce the sounds of other birds. This is a kite, for instance. This is a real kite. But this one is a bowerbird mimicking a kite. It's really difficult to tell the difference.
Yeah, it's very easy to be fooled by them, actually. So when we were looking at mimicry, we only classified it as mimicry if we could actually see the bird producing the sound, because it is, as you say, very, very accurate.
But it's not just other birds that they can mimic.
No, so they also mimic environmental sounds. So there's reports of them mimicking the sound of dripping water and twanging fence wire, wings flapping, and also people. So I've got a recording of a bowerbird, or two bowerbirds in fact, that mimic a lady calling for her cat, which is called Bonnie.
That's amazing. How long did it take for the bowerbirds to get that?
Well, the lady has owned the cat for less than a year, so they've picked it up in under a year. The lady also calls for the cat at least once a day, so they've only probably had 1 or 2 exposures to it daily, and then they've picked it up in under a year, so they can obviously learn them moderately quickly.
And how common is this for bowerbirds?
As far as we know, all bowerbird species mimic. To what extent they all mimic, we're not entirely sure. Because many of them are in remote locations, we don't always know as much about them as we would like to.
Now, Gavin, what do you make of this mimicking?
Yeah, I think it's true for many species of birds, and even the lorikeets that we're under pressure with now. These guys are known to be mimics, especially if kept as a pet.
What do you think's going on here, Laura?
Well, it's not entirely clear to us why this particular species mimics. So in some of the bowerbird species, they mimic as part of their sexual display. So as well as building their impressive bowers, they also produce mimicry of other species to attract a lady. With this particular species that I work on, the spotted bowerbird, it could be that they mimic aggressive and predatory species as a way of deterring either potential predators or rival bowerbirds. The other thing that it could be is that the sounds that the males mimic are all quite simple, and they're very common and loud in their general sound environment. So it could just be they're almost learning these sounds by mistake because they're simple and very loud.
So they could just be going on anyway, and the fact is there's no disadvantage to them mimicking rather than there being an evolutionary advantage.
Exactly, yeah.
Laura Kelly from the University of Edinburgh and Gavin Harrison from Edinburgh Zoo. This is the Planet Earth podcast, and last time I was reporting from a scientific expedition to the Arctic sea ice north of Svalbard. Well, after I left, the ship headed west towards Greenland with plenty more science to be done, including an experiment being overseen by Colin Griffiths from the Scottish Association for Marine Science.
Follow me, Richard. We're just going to the engineering workshop on the port side. Just open the doors. In we go.
Clamber in. Into the warm.
Well, Richard, as you can see, there's various bits of equipment being worked on the benches.
Mess would be another way of putting it.
And for the one that rather stands out in this space is the yellow submarine.
It looks actually more like a yellow torpedo. It's about, 3 metres in length and, I don't know, about 30, 40 centimetres across.
Well, that's a fair description of what we have here. This is an AUV, an autonomous underwater vehicle. And it's actually kitted out with oceanographic sensors, which you've actually seen elsewhere on sort of different devices.
So let's get a bit closer. Let's move round past the boxes and the bolts. You can see that things are being worked on at the moment. So, yeah, it is a yellow submarine. A small yellow submarine. It almost looks like it's got is this the rear here?
Yes.
There's almost like a conning tower sticking out at the top, only
Richard,
about a hand in length.
That's a fair description. We haven't got the prop on at the moment or the fins, which are at the rear. So this vehicle is actually powered. We can control it when it's at the surface. It'll float. We can speak to it by a Wi-Fi link. We also have a satellite link via Iridium, and we also have an acoustic link to the vehicle.
Now, as we speak, Colin, we're just heading back into Longyearbyen and Svalbard, north of Norway. So we've got some land around us, the steep cliffs, glaciers coming down to the sea, incredible scenery. Where you use this AUV, there's going to be nothing around you. And in fact, this is a really calm day. You're heading towards Greenland, some of the roughest seas in the world.
Yes, Richard. Well, fingers crossed they won't be too rough. But that's part of life at sea. All's great when it's calm, and hold on tight when it's not.
And what are you trying to find out? What will it be measuring?
It's actually measuring similar parameters to what we're measuring with. In fact, if we just look across the deck, we have what's known as a CTD. This is a instrument used on all oceanographic research vessels, and it's simply measuring conductivity, temperature, depth. It's actually measuring pressure. CTD sounds better. This is a standard piece of kit, and we can lower this through the water column, see the water structure below the ship, and we can take water samples. For the Remus 600 also has a CTD. So it can map the seawater as it actually travels along its course.
And what does that tell you, knowing this CTD, conductivity, temperature, depth? I guess conductivity, you're talking really salinity of the water, density of the water.
Yes, Richard, what we're after is salinity and then also density, so we can actually understand the actual dynamics of the water. We can also measure turbulence with the yellow submarine, and this is very important to understanding the actual dynamics of the seas, just the rates of mixing.
And the dynamics of the seas, the currents, that affects us all, doesn't it?
Yes, Richard, how the currents are moving, things that are actually being transported by the currents, heat transfer in particular. You have to understand these fine processes within the water. Very difficult to make from a ship, and hence the yellow submarine. And it's just one example of a new suite of instruments now, the robots. That's what we're talking about here, robots.
Colin Griffiths on the deck of the British Antarctic Survey ship, the James Clark Ross. And you can catch up with the latest from the expedition by visiting the blog on the Planet Earth online website. You can also see pictures from the trip and listen again to the podcast which we recorded on an ice floe. There can't be many podcasts that are recorded on ice floes. In fact, all our podcasts are freely available on the site, and you can download them as well from iTunes. In the next week or so, we plan to post some video taken by divers working under the sea ice. You'll be able to see that on our YouTube channel and Facebook page. If you enjoy the Planet Earth podcast, please do pass the word. I'm Richard Hollingham from Angus in Scotland. Thanks for listening.